So I thought I'd do something a bit different, and what I've been doing, if it's of interest, is experimenting with the random function and using for loops inside while loops, which is not ideal, but I was just looking at how to escape them, and I thought I'd do some live coding. Well, live whilst it's being recorded. So this is the book. I've referred to it in a previous video, and obviously real world stuff is the way to go, but occasionally it's always worth just digging back in and I don't know, just picking out a page. So today I've been looking at the section on data visualization, and it begins with generating data, and chapter 15, and eventually it goes from doing a random walk to generating some data to use with the Python package Plotly for bar graphs. So if you'd like to see me mess about with some code, what I've done is, for anybody who wants to follow, I believe the entire book is free to read online on No Starch, the publishers. Anyway, page 323 begins, and then I'm on page 324, and what I've done is I've written the class as per the book. It uses random, from random import Randint. There we go. We create a class of a die as in the thing you roll when you're playing a board game. Def init self number of sides equals 6 is the default, and then so that's what happens when the class is instantiated, and then we can call the roll function or the roll method, which then randomly returns a number between, in this case, between 1 and 6. So yeah, I've already typed that. You don't want to see me type from a book as such, although I'm about to. But what I'm going to do is, so from die, import die, so the class die is being imported from the die Python file, and then die equals die. So my instance of the class is called die.roll, so that's just the method which is running and generating some numbers. So what we want to do, as per the book, in the book, let's begin. So what we do is we create a list called results. Sorry, my typing is better than this, honestly. I've got the cable just going around the back of the keyboard, so bear with it. It may improve, may not. So results is going to be a list which will contain the 6, in this case 6-sided dice. It will contain the number of times that each number has occurred per sample. So what we want to do is we want to say something like for roll num in range, let's just do 100 to start with. So this, effectively we're rolling it 100 times, and then we want to do something like result equals die dot roll, and then then we want to add, or so append to results, the results list dot append So we're going to add this result to the list of previous results. And then if we do print results, let's just run that and I'll show you what's going to happen. As you can see, I've already saved it under Plotly, so die visual name results is not defined. That's because I've done a typo there. Let's do that. There we go. So 100 roles. That list should have 100 attempts, 100 rolls of the dice, and it has used random from here. Okay, so what we're going to do next is we want to, so if you're following the book does something like analysing the results. Oh yeah, in the book they go from running this 100 times and printing the result each time to running it 1,000 times and then just saving a list and the frequency of each number. So let's just quickly do that and then we'll get to the interesting stuff. So just going to comment out print results, because what we're going to do is change that to 1,000 as per the book. In a minute we're going to deviate from the book, so this isn't just me typing from from a book and running the code. We'll go off and we'll do some we'll do something slightly more interesting. Okay, so next we want to analyze the results. And we do for value in range 1 to die.num underscore sides +1, because yeah, it's upper bound or lower bound, I forget how you say it, but we need to make a list to store the frequencies of each equals. We need to store the frequencies of each the number of times each number on the dice occurs. So frequencies equals results dot count and then value. So we're counting number of times each value occurs per 1,000 rolls of the dice. And yeah, just the last bit here, I'm still just referring back to the book, if you excuse me. Frequencies dot append frequency, and then so that will give us a list of the results of 1,000 rolls of a dice, and then there we go. So if we run this, we should have, well, if 1,000 divided by 6 is just a bit under 200, so we should have 170, 180 occurring about 6 times. There we go. 182, 162, 171, 139, 169, 177. So what if we run it again? And again? And again? Now, the reason why I'm making this video is because I was following this book, and then I just, as is my tendency, I kind of want to tinker with someone else's code, and then I decided to try and keep running it as many times as was required until one of the numbers cropped up more than 200 times. And I was just really wanting to see how long it would take before one of those numbers cropped up 200 times per 1,000 rolls of a dice. You may think I'm strange for doing this, and that's, you know, you're entitled to your opinion, but if you're still watching and you want to see what I did next, then yeah, stay tuned. So right, this was just basically the code which allowed me to generate one line. Now, to do this more than once, and for me not have to keep doing up arrow enter, up arrow enter, up arrow enter, I wanted to make the computer do the hard work. So tap that in, and then we want a while loop. So while, if I do true, this will run and it will run very quickly, and it will, I'll just show you this. What a mess. That's pretty meaningless. So first thing I want to do is import time, and just to slow it down really, time dot sleep, and let's do 0.2. Let's do a bigger number, let's do 1. So after each cycle of 1,000, it'll pause for 1 second. So let's just get that in there to start with. There we go. What's the problem though? The list keeps appending larger and larger and larger, which is bad because we only want 6. 6 results at a time. So what I think we'll do, just move that down there, and let's frequencies needs to be inside the loop. And we need to clear it. So let's just put that in there and run it again. Why is that not working? Probably because I put it in the wrong place here. So let's put that back up near the top for now. Frequencies is empty, so that should then just limit it to 6, 1 list per go. Okay. That's well, that's better. That's tidying the screen up. So sorry, just realized this bit needs to go inside the while loop because we need to generate a new set of results each time. So for rolling 1,000, then do the 6 numbers, update our list called result. Let's just see if that runs. Good. So now we've got it's still appending each time. So we're actually generating we're modifying the list, but it's appending to itself each time. So we need to sort that out. Let's just stop that there. I'm just going to tidy this up a bit. Move that across slightly. Okay. What I'll also do is frequencies. Let's just clear that list and see what happens now. Okay, not. Sorry, edit that out. Delete. Right, results. We need to clear the results after each time. Otherwise, the results keep getting appended to the previous results. So let's try and run that. Better. That's good. So if you're following me so far, what we've done is we've written a class to represent a six-sided die. 6 sides. We instantiate it, or when it's instantiated with 6 sides as default. And then we've written a method which randomly rolls it, simulates rolling a die. Dice is plural, die is singular. So there in our main file, we create an instance of it called die. We roll the die, and then results is empty. That's just the list. And then to simulate running that, we run the while loop, we roll it 1,000 times and append the results to the list. So each time it goes through there, it will store a number between 1 and 6 in the list. Then we generate what actually ends up appearing here, the list which stores the frequency of that particular number, the count. So we count how many times that value between 1 and 6, we count how many times that value appears in the results. And the results is obviously the list generated by 1,000 rolls of the dice. So next we want to roll that 1,000 times, and we want to see want to keep doing it until we want to try and kind of get random to do something strange. So we want to see if we can get random to select one of the 6 numbers over 200 times per 1,000 rolls. So let's do that. So what I'm going to do, let's just, I'm going to put that sleep right at the end actually. There's no need for that to be in the middle. Okay, so what we want to do is we want to check for more than 199 of any number in, I'm putting 1,000 rolls because that's what I've put in here, but we could obviously change that to a variable, but for this purposes we're going to stick with 1,000 rolls. So we've got a list called frequencies, which is what we're seeing here. So we need to say something like for I in frequencies, if I is greater than 199, so if that number on the die crops up more than 199 times per 1,000 rolls, then we need to say number on the die equals frequencies dot index. So we're going to create a variable that we can use in our output that tells us which of the 6 numbers was the one that cropped up more than 200 times. And let's print some output. So print use an f string frequencies. So this is going to say something like 201, 202. Took, and then we want to we need to have a variable called count, which will tell us how many attempts, how many sets of 1,000 rolls did it take to get 200 per 1,000. Okay. Count. We need to start a counter. Let's count equals 0, and then at the start of our up here we'll put count equals count plus 1. Okay, so next we want to find a way how to exit, because we want to exit once we found our iteration which produces the 200. And then we need to say if x equals false, and then we need to break out of the while loop. Let's just tidy all this up. I think all of this should actually be inside a function, because you should be returning a returning value here, which allows you to exit the loop. This is a bit of a messy way of doing it, but let's just see if it works. One 187, 196. One nine nine. Ah, I said greater than 199. Right, easy way to troubleshoot, or let's just test this with a slightly lower number. So let's do 190. Run it again. While true, we need to say while x. Let's try that. Okay, x we haven't defined. X equals true to start with, otherwise the loop's never going to run. Good, right. That took 2 attempts to get a number higher than 190. Number on the die was 5. So 1, 2, 3, 4, 5. Yeah, that just shows we've got our indexing right, because we had to use index plus 1, because obviously the indexing of a list begins at 0, so 0 is no use on a die. So we're going, yeah, 1, 2, 3, 4, 5, 6, rather than 0, 1, 2, 3, 4, 5, which would be the indexing within the list, if that makes sense. I hope it does. Well, let's try the bigger number. So we really want to just have this, and I'm just going to make the time.sleep a bit faster. 0.3. And so now it's going to run 3 times as quick, and it's looking for where it's done 1,000 rolls and a given number has occurred more than 200 times. So let's go. And this could take a while. "42 attempts, and number on the die was number 5. I'm going to just change this down a bit, make it a bit faster. I don't want to make it so fast that you can't see it on the screen while we're testing, at least. Let's do it again. So can we do better than 42? 42 attempts. So that's 42 lots of 1,000 rolls. So that's 42,000 rolls to get 42 lots of 1,000 rolls. Sorry. 146 attempts, and the number was 5. Okay, I'm going to make this even faster now. I'm a bit concerned as to why number 5 keeps cropping up. Let's see if we can get another number that crops up. Number 2, that's better. Okay, so I hope you're getting the gist of this. What we're doing is we're rolling the die using the random function and our class. We're saving the results to a list, and then we're checking that list like Santa Claus does just before Christmas to see who's been naughty or nice. And yeah, 54 attempts. So I had to do 1,000 rolls 54 times before one of those sets of 1,000 rolls produced the same number 200 times. And oh yeah, I know a little adjustment we can also make to this, which, so I am looking up some notes here. Print frequencies. Let's rather than, so the frequencies, all this is happening inside the got insert turned on there. What the sorry, it's just done a screenshot. I was trying to right, forgive me. End equals \r quote return, and end equals \r return. That should now get all the results. Each one of this list should overwrite itself on the same line each time. Yeah, there we go. Hope that makes perfect sense. So you see what I did there. because it's inside a while loop, it's going to obviously loop through this each time, and that's what's producing row after row after row after row of results. Just to kind of make it tidier, and we don't really want to see all that output, especially if it's taken 54 attempts. We only want to see how many attempts it takes. So run it again, 20 attempts there to get a 200. Hope you like this. I think it's pretty cool. It's kind of you can see where kind of random is useful, particularly with games. 174. So look, we've gone 54. So effectively, what we're doing is we're randomly choosing something which has already been made random. 54 attempts, 20, 174. What do we? No, it's gone 2, 5, 6. Number 2 again. It only took 6 attempts. This really is quite random. 38 attempts to get 4 occurring 200 times. And 24 attempts to get a number 2. So this is a bit random. I know you're probably used to watching my sort of attempts at web scraping and using Scrapey and tinkering with all sorts of Linux code and so on. But I just wanted really to experiment with the random function and kind of not really mess with your heads, because that's not really what this channel's about. This is kind of a channel to show tutorials or demonstrations, and really this has just been, I would say, a demonstration of using a list to store output of using the random function, and then to automate the creation of random data and automate the creation of random data and keep going until we get what we think is quite a rare result, which is getting the same number 200 times out of 1,000 rolls. And well, it's a bit like winning the lottery. So yeah, I hope you've liked this. It's just really a bit of experimentation, but yeah, some things to take away from this are writing the output over the top of itself on the same line. That's really useful. So you do print whatever you want to print, and you're doing it within a for or a while loop here, but you could be doing a for loop. And then rather than keep printing it row after row after row, just to get it to print on the same line, it keeps overwriting itself, you do /r. And yeah, appending to a list, that's very common. And yeah, results.count, so that's where you count the number of times a value occurs within the list of results. And yeah, index, so if you want to know what position within a list your chosen character or your chosen number is, then you do list.index and then whatever the iterator is. I've done I, but it can be anything. In general, I is kind of I've read that I is a legacy thing from C++, so with Python you can make it more meaningful, because again here you could have done for I in range there, but in the end you end up with so many I's and it's meaningless. So yeah, what you could do here is what would you call it? Doesn't really matter, does it? But for pattern in frequencies, whatever. Yeah, all of this could actually go inside a function, and then you wouldn't need to use break. Break is how you exit a while loop deliberately. If you didn't want to break, if you want to, if something keeps failing and you don't want to break out of the loop, but you want to keep going back to the start, then instead of break, you'd use continue. So you may have seen password programs where it prompts you for a username and password, and it gets halfway down through the code, it checks the password. If it's not suitable, then it just does continue, and that takes you back up to here, which is back up to the start of the while loop. Up to here rather, the count would still increment. So yeah, I'm not going to put this code on GitHub really, because it's kind of just experimentation, and it's not actually my code really, because this bit and well, chunks of that bit there and that bit there came from this book. So I'll leave you with that. I'll probably do something a bit more structured next time, but yeah, it's good to mix it up.